Okay. So first thing we're going to do is 2 part 3. We are doing inequalities, quadratic inequalities to be precise. Alrighty. We have minus 2x squared minus 7x equals greater than or equal to 0. So the first thing I'm going to identify is that it's an n-shaped function. Everybody cool? That's an n-shaped function. Okay, it's definitely an n-shaped function. Now I'm going to solve it equal to 0 anyway. So I'm going to multiply both sides by minus. So it's 2x squared plus 7x equals 0. Going to take out x, and what we're going to be left with is 2x plus 7 equals 0. And then after that, what we're going to get is x equals 0, or 2x plus 7 equals 0, 2x equals 7, x equals minus 7 over 2, otherwise known as 3.5. Now, you go in and you draw your graph really quickly. It's an n-shaped graph that crosses at 0, and it also crosses at, minus 3.5. And there's your n-shaped function right there. Now the question is, there's generally 2 answers. There's the yellow region, or there's the blue region. Which one are you being asked for? So you have to go back to the start of the question again. It was greater than or equal to. So are you asked for the blue region or the yellow region? That's what I need to ask you. Blue or yellow? Blue. Why is it the blue region? It's above the x-axis, which means it's above 0. Yeah? So, yes sir?
I don't like the
Oh, it does, but that's just for solving. That's just for solving. The U-shaped graph and the N-shaped graph cross at the same 2 points. All what we're doing when we multiply by minus 1 is just solving. We're not actually using it to solve the inequality. So we go back to the very original question, which is N-shaped, and we draw an N-shaped curve and we say, okay, where is it bigger than 0? Okay? So it's bigger than 0 here. It starts at minus 3.5 and it ends at 0, so it's going to be minus 3.5 less than or equal to x less than or equal to 0. Only because there's a less than or greater than or equal sign up here. If I change that to a greater than sign, what would happen? If that was just greater than and not greater than or equal to, what would that mean? I'd get rid of the equal signs in the answer as well. We all good? Alright, we're going to move on to question 6 now. So where is question 6? Oh, it's on the next page, is it? Oh, sorry, question 4. Alright, we'll do question 4 now. Keep those crosshairs, so to speak. There we go. Now, let's just multiply this out. So we're going to get 4 times 1 is 4, minus 4x, minus 1x, plus x squared. Bring over the x and 11 onto the left hand. Oh, sorry, won't do it. We'll do it in 2 steps. Now we're going to have x squared minus 5x plus 4. Bring the x and 11 over the other side. Minus 1x minus 11 less than 0. We good? Next thing we're going to do is x squared minus 6x minus 7 less than 0. Solve it. It's U-shaped, isn't it? Just solve it normally, and you'll get x minus 7 and x plus 1 equals 0, x equals 7, and x equals minus 1. Minus 1 is there, 7's around there. U-shaper. No. Now once again, you have 2 answers. You have the blue answer, or you have the 2 green parts. Which one are you being asked for? It's smaller. Smaller would indicate the blue part. So what are the x values in the blue part? Start at minus 1, end at 7. So minus 1 less than x less than 7. I'll pause it there. Alright. Lads. Come on. We already did these. When you see the real roots, what does that usually mean? Alright, you see, yeah. What one? I say bigger than or equal. Because equal roots are real roots. You get what I'm saying? Equal roots are also real roots at the same time. So if it's bigger than 0, it's two distinct real roots. You understand what I mean by two distinct real roots? Two numbers that are different to each other. Like x, 1 and 3. If it's equal to 0, it's a repeated root, which means, let's say, x equals 2 twice. You get what I'm saying? So you got to be careful about that. When it says real roots, you're talking about bigger than or equal to 0. Okay, that's the first thing. What's the A value? B value? C value? 1. And then you're going to end up with a quadratic. Now, it's very important you figure out, is it going to be U-shaped or N-shaped straight away? Which one is it? U-shaped or N-shaped? U-shaped or straight away. You know that. Very important you do that at the very beginning. Okay? So it's going to be k plus 1 by k plus 1, which we all hopefully know by now is k squared plus 2k plus 1. Take away 4, greater than or equal to 0. K squared plus 2k, take away 3, greater than or equal to 0. And then, what are my 2k values then? K plus 3, k minus 1. And then we get k equals minus 3, k equals 1. So, it's minus 3 and plus 1. So, along these lines. Okay. Now, here's the fun part. Which part are we looking for? We'll go for blue part or pink part. Which one? Why is it the pink part? It's where the y value is bigger than 0, okay? So what are my two answers then? K smaller than or equal to minus 3. Anything to the left of minus 3 or anything to the right of 1. So k greater than or equal to 1. We're good to go. Real roots greater than or equal to 0, yeah? Pretty much what we did already. A equals P. B equals P plus 3. C equals P. Squared minus 4AC greater than or equal to 0. P plus 3 squared minus 4 times P times P. P squared plus 6P plus 9 minus 4P squared. Are you guys doing a U-shaper or an N-shaper? Huh? It's an N-shaper, okay? Huh? Oh, yeah, thank you. I was wondering what happened there. It didn't work. So it's an N-shaper, lads, okay? So you need to remember you're going to be working with an N-shaper, okay? 2 multiply both sides by, divide both sides by 3, and you get P squared minus 2P by 3. We want the pink region, don't we? So what would the answer be? Has to be bigger than 0, so what's the answer? In inequality terms, minus 1 is smaller than or equal to P smaller than or equal to 3. Alright, so I'm going to skip forward to question 12 now, okay? And I think it's 12. I want between -1 and 3. Do you get that? Any p-value I want. So, for example, is if I choose p equals 1, this will make this 1x squared. 1 plus 3 is 4x plus 1 equals 0. Do you see that? What if I choose p equals 2? What happens there? P equals 2. 2x squared plus. Now, I potentially got lucky here, did I? Because x might be the actual answer to this question. X equals -2 could be an answer for this. Let's find out if it is or not. I'll do it your way for once. What's it? A +2 there, isn't it? A +1 there. And x equals -2. Now, I found my answer by trial and error there, didn't I? It's a bit like try them out, see what happens. Is there another way we could do this question without doing trial and error? Yeah, that's the one. So what Phelim said there was, instead of doing trial and error, which I just did up here, why don't you just replace x with -2? If it is a root, when you replace x with -2, it has to cause it to become 0. So you'll see that that's going to be 4p. Oh wait. Totally messed that up there. That's p plus 3 times -2. So that's -2p minus 6 plus p equals 0. Then you get 3p minus 6 equals 0. 3p equals 6. P equals 2. There's your answer. We knew that p had to be in between -1 and 3. And when x equals -2 is a root, it means the p-value has to be 2. Alright, as well worth doing that question. Alright, let's move on. So, back in the day, first thing you're going to know about every question is there's a banned value. Why is there a banned value? A value that's not allowed? Alex? It will turn the denominator into 0. You're not allowed to have the denominator as 0. So what happens if I plug in x equals -3? What happens? Denominator 0. And over here, if I plug in x equals 1, denominator is 0. And what you see is when you graph these functions out, there's actually no value for those. When x equals 1, there will be no y value. The graph actually just stops moving, the graph has a gap in it. It curves up, gap, and then it continues on later on. Okay? Now, next thing we gotta worry about next is, back in the day, we learned a very basic rule about inequality. So, for example, is, if I said 5x is bigger than 10, everybody happy? You'd just say x is bigger than 2. Everybody knows that, yeah? Now, if I said -5x is bigger than 10, what would you do? What's the next step then? Huh? Multiply both sides by minus, and you get x is smaller than -2. Now, what I want you guys to think about is this, alright? What happens if I present -5x differently? What happens if I present 5x as 5x divided by -1? See what I'm saying? Would you agree it's still the same question? What is 5x divided by -1? Still -5x, isn't it? What happens if I bring the -1 over here? I cross multiply it, so to speak. What has to happen when I cross multiply a negative number? The sign, sorry, that's a 10. The sign changes. Would you agree with that? You cross multiply a negative number, the sign changes. It's just another way of looking at it. Now, my problem with this question up here is, I can't guarantee x plus 3 is positive or negative. I don't know which one it is. Would you agree with that? I can't guarantee if it's positive or negative. So I don't know what way you would do it. Okay? So we have to think of an alternate method. So let's try out, there's two ways of doing it. I can try the first way is like this. I'll see if it works. Okay? Two scenarios. Scenario 1 is x plus 3 is positive. Scenario 2 is x plus 3 is negative. So for example, if somebody's wondering what I'm talking about, imagine x equals minus 7. What would that do to both denominators? It turned them negative. So I wouldn't know whether to change them or not. Okay? So here's what we're going to do. Scenario 1 is it's positive. So let's assume it's positive. So 2x minus 7 less than, what's 1 multiplied by x plus 3? Just x plus 3. Happy enough with that? Scenario 2, x plus 3 is actually negative. So what would you do this time? You change the sign, don't you? So it's greater than x plus 3. You feel with that? Bring it over and you get 2x minus x greater than, what's it, 3 plus 7, x is greater than 10. This seems wrong. We'll run with it for a minute. Okay, what about the next one? Move this over to your side and what you get? 2x minus 1x less than 10, and then x less than 10. Now, you can see if you try this method, isn't going to work, is it? That answer seems absolutely useless, doesn't it? So that ain't going to work. This doesn't work, right? So they devised the second method, or the proper method, and here it is. With inequalities, I'm allowed to multiply both sides by a guaranteed positive number, am I? So what would be any guaranteed positive number you want? If I multiply both sides by 4, I get 20 bigger than 12. See the way the sign doesn't change around, yeah? Now here's what I suggest. Would everybody agree, is this a guaranteed positive number? Is this one a guaranteed positive number? And finally, is this one a guaranteed positive number? Can anybody tell me why did I choose these 3 examples to show you? They're the denominator of each part of this question. Use x plus 3 squared for the first one. Use x minus 5 squared for the second one. And finally use x minus 1 squared for the third one. Do you see the way? Now, I'm going to multiply both sides by x plus 3 to be squared. So example is I'm going to do 2x minus 7, x plus 3, and I'm going to multiply both sides by x plus 3 to be squared. What am I doing there, guys? I'm multiplying both sides by a guaranteed positive number. Therefore, I know the inequality signs do not reverse. Does that make sense? Do you guys reckon you could take it to the finish line from here? Just cross that, multiply out both sides, bring the x squared to one side and solve. Off you go. Okay. All going well. You'll have 2x squared plus 6x minus 7x 21. X plus 3 squared is x plus 3 by x plus 3. And you multiply it out, you get this. Right, next thing. You get 2x squared minus 1x squared minus 1x minus 21. And then minus 2x minus 9. And then it's x squared minus 7x minus 30. Yeah, that's nice because that's 10 and 3, isn't it? Well, one of them's a minus, the other one's a plus, so minus 10 and 3. And then you get x equals 10 and x equals minus 3. You draw your, is it a U shape or is it? Yeah, you start off with a U shape or so. 10 and 3. Oh shit, wrong way. Just realised I recorded that on video. Now, minus 3 and 10. So we're going underneath, aren't we? So that's underneath. Just there, isn't it? So what do we get then, guys? Huh? Minus 3 less than x less than 10. Is that okay? Cool. Alright, you're going to do all these questions in the same manner. the likes of question 11 and question 12, you're always going to get the denominator and multiply by the square of the denominator both sides. Everybody cool with that? That's the gist of those questions. Now, finally, if I was to do question 14, okay. Good man. Oh, it's automatically like this now. That's good. Alright. So, if I was to do question 14, what you want to show is, show that this is bigger than, for all values of x. Alright. What's the only way to prove something's always bigger than 0? You're going to have to form some form of perfect square, aren't you? Would you agree with that? How do we form a perfect square? Does anybody remember? You half the middle part, and what do you get? X plus a half squared, don't you? Now, what's x plus a half by x plus a half? X squared plus a half x plus another half x plus a quarter. Would you agree with that? And finally, it's going to be x squared plus x plus a quarter. Are we too big or too small? Too small by 3/4. And then, long and behold, you're going to get x plus a half squared, which is a guaranteed positive number, plus another guaranteed positive number, which will result in a number always bigger than 0. For homework tonight, don't worry if you didn't get that down. You're doing 7, 9, 11, 12, 14, and 15. And you can obviously take down number 14 later. I have it done online here, so you can do it later on. Yes? You always do the perfect square when there's a denominator. So see question, see the likes of question 12, 11 and 12. See 11 and 12. See the way x minus 1's on the bottom. Do x minus 1 squared top and bottom. Okay? And you do perfect squares also when you're trying to prove something's always bigger than or equal to 0.